Question 1 in this learning quiz is about straight lines and parallel and perpendicular gradients. So we're given the equation of a straight line, which is y equals 2x minus 3. And part A and B both ask us to write down. So the command word write down means it should be really straightforward. Write down the y-intercept. Well, clearly that's just going to be here. If we remember that the equation of a straight line is y equals mx plus c, where m is the gradient and c is the intercept. So write down the intercept is going to be 0, minus 3 as coordinates, and the gradient is going to be the coefficient of x, so we've got 2 in front of the x, so the gradient is just going to be 2. We're then told that line 2 is parallel to L1 and passes through the point here. So if we're told that it's parallel, what we can deduce is that they must have, the two lines must have the same gradient. Right? If they're parallel, it means a slope, the rate of change, the gradient is going to be the same. So our line L2 must start y equals 2x because it must have the same gradient. This point here, if you think about it, is actually the y-intercept. If the value of x is 0, the y-intercept is 3. So we've got a straight line that goes through that point and has a gradient of 2. So the equation of that straight line must be 2x, the gradient, plus the y-intercept, which here is 3. So that's going to be 2x plus 3. Right, we're now told that line 3, L3, is perpendicular to L1 and passes through the point negative 2, 6. Now this is the one which was done really badly and was the reason I included this question, because historically this always catches people out. So this is the one you want to pay attention to. Right, so the first thing here is, again, to make connections with the gradient. So previously we said if they are parallel, it meant the gradient was the same. Here, if we've got a line which is perpendicular, we know that the relationship between two lines which are perpendicular is that they are the negative reciprocal. Okay, so if we have the gradient of the first line, which we said is 2, then the gradient of line L3 here would be the negative reciprocal. So that just means make it negative and flip it upside down. So if this is the same as 2 over 1, so make it negative and flip it upside down, that will give us a gradient of negative a half. The other way you can think about it is that if we multiply the two gradients together, they are going to give you negative 1. So in this case, because we know that line 3 is perpendicular to line 1, the gradient of line 1 is 2. If we multiply that by the gradient of line 2, we'll end up with negative 1. And we can rearrange that and get m2 is equal to a negative a half as well. Either of those methods is fine. Right, so we've worked out the gradient of L3, then is negative half, and then finally we're asked to find the equation of L3 in the form ax plus by plus d, where a, b, and d are integers. So let's go back to what we know. The equation of a straight line, y equals mx plus c, and substitute in what we know for L3. So for L3, we've worked out the gradient, so we can substitute that, negative a half. And we've got the points, the pair of coordinates where it passes through. So the y coordinate is 6, so 6 is equal to a half times x, which is negative 2, plus c. Now we don't know what c is, but we can work it out from here. So we're going to end up with 6 is equal to 1 plus c. So we can rearrange that to say that c is going to be equal to 5. So if we put that back in our equation, we can then say that y equals negative a half x plus 5. However, we're told that a, b, and d have got to be integers. So, and we want to give it in the form x plus by plus d equals 0. So, if we rearrange that, we are going to have half x plus y minus 5 equals 0. So what we're going to have to do is multiply 3 by 2 to get rid of the fraction. So if we multiply 3 by 2, we will end up with x plus 2y minus 10 is equal to 0, which is the final answer.